Which of the following is our convergent for options given to us, and we have to check convergent series. In option A, B, C, D, you can see there are different series and we need to check convergence. So to check convergence, we have many tests, but most commonly used tests are ratio test, root test, and sometimes limit test. What these tests says limit of an upon an plus 1 when series is summation an is given to us, then if this limit is L, if this limit is equal to L and value of L if greater than 1, then in this case series will converge. If L less than 1, then series diverge. If L equal to 1, then test fail. In the case of root test, we need to compute limit of an raised to the power 1 upon L is equal to 1 upon n is equal to L if L greater than 1, then diverge. If L less than 1, then converge, or and if L equal to 1, then test fail. Every convergent series, if series is convergent, then limit of an is always 0. If limit of an is not 0, then directly we can say series is divergent. So we will check each option one by one and predict the convergence. First series is given 2 raised to the power n, sorry, not 2 raised to the power n, it is 2 raised to the power minus n into n square. So for this we can compare this one with summation an. So value of an is n square into 2 raised to the power minus n. So I'm going to apply root test because of n is involved in the power. Whenever n involved in the power, always try to find convergence with the help of root test, because of this n will somehow cancel out. Or if you apply ratio test, sometimes ratio test fail to predict the convergence of some series, but root test can predict. So indirectly I can say root test is more powerful than ratio test. So for root test, we need to compute a limit of an raised to the power 1 upon n. For this, I can write limit n tends to infinity n raised to the power 1 upon n square into 2 inverse. So limit of this one is 1 into 2 inverse. So finally, I got 1 upon 2, which is less than 1. So series is divergent with the help of root test. For option B, summation. What is option B? Option B is n raised to the power minus 2, 2 raised to the power n. Again, I am going to apply root test. Limit n tends to infinity n raised to the power minus 2 raised to the power 1 upon n into 2 raised to the power n raised to the power 1 upon n. So finally, I got limit n tends to infinity n raised to the power 1 upon n raised to the power minus 2 into 2. So what we have? We have 2 which is greater than 1. In this case, series is divergent by the ratio test, root test. Now option C is summation 1 upon n log n. Whenever this series is given of the type n log n raised to the power p, this series is convergent when value of p is greater than 1. This series is divergent when value of p is equal to 0 or greater than p and less than 1. So in this series, we can see value of p is 1. So this series is divergent. In option D, series is given to us 1 upon n log 1 plus 1 upon n. So expand this series with the help of log 1 plus x, and this expansion is x minus x square upon 2 plus x cube upon 3 minus x raised to the power 4 upon 4, and so on. Using this expansion, I can write an 1 upon n into 1 upon n minus 1 upon n square into 2 plus 1 upon n cube into 3 minus 1 upon n raised to the power 4 into 4, and so on. And take the common 1 upon n from each term. So this n will cancel out, and what we will have a n equal to 1 upon 1 minus 1 upon n into 2 plus all terms containing n. So whenever I will take the limit of this a n when n tends to infinity, I have 1, because of other term will go to 0, and this limit is not equal to 0, so I can say this series is divergent. So only convergent series is given in option A.